Hello. So today what we're going to do is we're going to talk about congruent figures, right? So this is the first lesson that we're going to talk about with triangle congruence. So what are congruent figures in the first place, right? We've talked a little bit about the word congruent in the past, right? It means two things that are the same, right? So specifically here, congruent figures are going to be two figures with corresponding parts that are equal, right? So corresponding, another word that we've learned about this trimester, right? Corresponding means that they're kind of like in the same location, right? So these are two figures where all of their things that are kind of in the same spot are all equal to each other, right? When we're writing this out with notation, right? If I have triangle ABC, right? Remember that we named triangles by 3 letters. And then a little bit further on, I had triangle DEF, right? The way that I would show that these are congruent is with the same symbol that we learned about weeks and weeks and weeks ago, right? It is this squiggly over the equal sign, right? That symbol is telling me that, oh yeah, those are congruent. That's the symbol for being congruent, right? So we got a couple things that we can talk about when we have congruent figures, right? They're the Abcd Theorem because it starts with A, B, C, and D. So again, we're not really worried about what it's called. It's more about what it's trying to tell us. So we're saying that if two figures are congruent, right? If I have two things that are the same, then all of these will also be the same, right? All of the corresponding angle measures will be the same, right? If I have a right triangle, a congruent figure would also have a right angle in it, right? It would also be a right triangle. The B is for this thing called betweenness, which is kind of a weird thing to think about. What it's saying is that, say I had, a line as part of my shape. And on that line, or on line segment, I had 3 dots, right? Let's call them like Q, R, and S, right? So then if I had this as my original, and then I had another shape that was congruent to whatever this is in, this point, whatever corresponds with R, is going to still be between the ones that kind of match up with Q and S, right? So if you have something that's between two other things, then that will also stay the same, right? That's not just true for the lines, right? Because that's kind of our next one is collinearity, right? If 3 things are collinear together, then they are still going to be collinear, right? Betweenness also kind of talks about like, if it's like in the middle between a couple of different things, right? That's what it's kind of trying to say. Distance is also preserved, right? That also stays the same. If I have, if it's 3 centimeters to go from Q to S, it's still going to be 3 centimeters to go from, fake Q and fake S, right? In the new figure, if it's congruent, right? So the distance doesn't change either. All of these things stay the same, right? We got a couple of theorems that kind of state that a little bit more clearly, right? And it's, I guess it's kind of saying it backwards, right? We're saying that 2 segments are congruent if and only if they have the same measure, right? It wouldn't make sense to say that, this segment and this segment are the same thing unless they are measured the same, right? I can't say that, oh yeah, this one's 5 centimeters and this one's 2 centimeters. Those are not the same, right? So they wouldn't be congruent. Same thing goes for angles. 2 angles are congruent if and only if they have the same measure. All right, so I know we just filled in the same thing for both because they're pretty similar. You can only be congruent if you have the same measure as what you're trying to be congruent to, right? So let's take a look at a couple problems, like what these types of things might look like. So in this figure, we know that CL is the same thing, right? It's congruent to AR. Right? So let's go ahead and mark that on our diagram. CL is right here. So I'm going to put a little tick mark on there. It's telling me that it's congruent to, right? It's the same distance, as AR. Let's try that one again. There we go. So CL and AR are the same. If it's asking me, about CA, this distance here being 36 miles, it wants me to figure out what LR is. Right? So let's kind of think it through, right? We know that those red pieces are the same. So the 36 miles that I've got in blue on the left, right, from C to A, that's made up of, that red lined piece and then also this extra little chunk in the middle, right? Well, the side on the right, getting from L to R with the black ink there, is also made up of that same kind of red piece plus that piece that's in the middle, right? So because we know that those red parts are congruent and they share that same thing in the middle, then we can say that this is also going to be 36 miles, right? So those two pieces with the red are the same and they share that same middle piece. So we're just gonna say that, all right, these are both 36, right? On this one, try this one out, right? The figure below, MA is the same thing as TH. If MT is 25 miles, try and figure out what AH is going to be. All right, so if you haven't yet, try pausing here, right? See what the other side is going to be from A to H here. All right, so hopefully you gave it a shot, right? Let me try that dash a little one more time. All right, so this is actually just the same thing as the last one, right? We know that those red pieces are the same. So that 25 miles in blue is made up of a red piece plus this highlighted piece in the middle. Well, that piece on the right, from A to H is also made up of a red piece plus that piece in the middle. So that's also going to be 25 miles, right? So I know that seems pretty basic, right? But this is actually what what we can do when we're congruent, right? If we didn't know that they were the same, we wouldn't be able to do that. All right, let's take a look at some angles. In this figure, we know that angle GOV is congruent to angle ANK, right? So again, let's go ahead and mark that. GOV is this entire thing right here where I'm putting the red down. ANK is this other one where I'm putting the second little red mark. Right? The next thing that it's telling me is that OS bisects that angle GOV, right? So OS over here on the left one is cutting that red angle in half, right? So if the measure of GOV is 12x minus 2, the measure of ANK is 8x plus 34, we want to figure out the measure of angle 1 that's right in there, right? That's what it wants me to find as angle 1. All right, so how are we going to do that? We're going to need to know what angle GOV is, right? And then split it in half because that's bisected there. So what I'm going to need to do is I know that 12x minus 2 and 8x plus 34, those are the measures of those angles in red, right? I know that they are supposed to be the same, so I'm going to put an equal sign between them. Right? When I do that, it turns into an equation that I can just solve out, right? So I'm going to go ahead and do that. I'm going to move all my x's to be on one side, so I'm going to subtract 8 to do that. Move those over to the left. So I have 4x minus 2 equals 34. After that, I need to move that 2 away from the x. So I'm going to add 2 to both sides. So we're going to get that 4x is equal to 36. Last but not least, to figure out what x is, I need to get rid of that 4. So I'm going to divide by 4 on each side. So x is going to equal 9. All right, cool. So x is equal to 9. So I still have a few more steps to go. Even though I know that x equals 9, I still need to figure out the measure of angle GOV. Back up in the problem there, right? That's 12x minus 2. Right, so if I do 12 times that x we just found out was 9 minus 2, that's going to be the measure of angle GOV. Right? So 12 times 9, I think that's 108. Hold on, let me double check. Never a bad idea. 12 times 9, 108. Cool. It's 108 degrees minus 2 equals that measure of angle GOV. 108 minus 2 is just 106. Right? That's the measure of angle GOV, right? And actually the measure of both of those red angles. So if I want to figure out the measure of angle 1, right, we know that it's going to be half of that much, right? Because we bisected the red angle. So if I want to figure that out, I need to take 106, chop it in half, right? Divide by 2. That's going to give me 53 degrees for that measure of angle 1. right? After we get to there, that's it, right? That is the measure of angle 1. That's all we needed to find, right? So I know that this seems like a lot, right? We did do 3 different things in this one problem, right? So first thing I would suggest doing is mark the information on your diagram, right? After that, anything that you know is equal, right? Like these 2 red angles there, you can use that to help you set up an equation, right? The equation is probably going to end up having you solve for some sort of x or a y or whatever variable is floating around, right? And then comes the part where you just got to like plug it back in and figure out your final answer, right? So markings on your diagram, set up an equation and solve it out, plug it back in and kind of get towards what it's asking for, right? So if you're feeling pretty confident in that, what I'd like you to do is try out the next one right below this, right? If you want to pause here and just keep this one on the screen, it's not a bad idea. If you're feeling a little iffy on it, right, that's okay. Follow along with what I'm doing. All right, so hopefully some of you tried this out. In the figure below, we know that ABC is the same thing as EFG, right? So ABC, where I'm putting the red in, is the same as EFG with the other red. We know that BD is bisecting, right? So again, splitting that ABC in half. If the measure of ABC is 16x minus 4, and the measure of EFG is 4x plus 20, we want to find the measure of angle 1, right? Which again is half of this, right? It's half of that red angle that's there. All right, so let's take a look. Same deal, right? I marked my stuff on my diagram. I'm going to use that to help me set up an equation. I know that those angles that I've got marked in red are equal to each other. So 16x minus 4 is equal to 4x plus 20. All right. After that, I'm just going to solve this out. I'm going to move all my x's to be on the same side. So I'm going to subtract 4x from both sides to move that to the left. It's going to land me with 12x minus 4 equals 20. I need to now move that 4 away from the other x's. Oops, sorry about that. So we're going to get that 12x is equal to 24. One last little bit to finish solving for x is that I got to get rid of that 12. It's going to lead me to divide both sides by that 12. So x is just 2. All right, cool. So 2 parts down, right? We started with the labeling. Now we set up and solved the equation that we needed. And now to figure out the measure of angle 1, right? I know that it's half of the measure of ABC, right? So ABC is 16 times that x we just found minus 4, right? That's the measure of angle ABC, right? After that, 16 times 2 is going to give us 32, right? And then we're going to subtract that 4 to bring us down to 28 degrees. That's the measure of ABC. Last but not least, I'm going to need to take that 28 and I'm going to divide it in half, right? We bisected that angle. We split it. So what that's going to do is it's going to land me with 14 degrees, right? That's what each of those little pieces of, like ABD and DBC are in there, right? That's the measure of angle 1, 14. Right? If these problems seem a little bit difficult, it's because there's a lot going on, right? They are not super duper easy, right? If you feel like you get them even partway, then that's awesome, right? We got a little bit left to talk about, right? And then we're almost done already. We've got these corresponding parts, right? So when we're saying corresponding parts, right, I kind of clued into it a little bit earlier. They are pieces of congruent figures in the same location after a congruence transformation, right? Say that 5 times fast. So what we're talking about are things that are in the same kind of location, right? Even though we've kind of done something to our shape, right? We might have flipped it over, we might have rotated it, we might have moved it around a little bit, but we're still talking about the same side of a triangle, for instance. So that leads us into some weird name theorems, right? One of which is the corresponding parts of congruent figures theorem, or CPCF. Again, not really worried about what the name is, more just worried about what it's saying. This one's telling us that if 2 figures are congruent, then any pair of corresponding parts are congruent, right? So if you know that the shapes are the same, if they're congruent, then you can take any corresponding pieces and say with confidence that they are also going to be congruent. Right? On the next page, we've got a couple more theorems here, right? We're going to talk about congruent triangles. So specifically for triangles, they need to have the same side lengths, and also need to have the same angle measures. Right, so side lengths and angle measures need to match up in order to have congruent triangles. Right, I talked a little bit about congruence transformations. I've just got them listed out there, right? If you reflect, rotate, or translate the shape, then it will still give you a congruent figure to that original one, right? If you think about it, when you're reflecting something, right? If you just kind of like reflect it in a mirror, you're not changing the size of any piece of it. You're just kind of flipping it over. Right? If you think about rotating, again, you're not changing anything about it. You're just kind of like, rotating it around. And translating, all that means, if you don't remember from way in the past, right? Translating is just when you're moving it around, right? So if you imagine, if you had like a triangle of paper, right? And then you had another identical triangle of paper on your desk, right? If you take that second one and you just kind of like flip it to the side, right? If you flipped it just like that, right? That would be a reflection, and you wouldn't have changed anything about it except for just kind of how it looks on the paper on your desk. If you rotated it, right? If I just, turned that from a like flipping arrow into a rotating arrow, if I just kind of rotate it 90 degrees to the side, it's still the same shape, right? And then translating is probably the one that makes the most sense out of all of them. If I take that triangle and I just move it, and apparently everything else, if I move it all down there, right, it's still the same shape. I haven't changed anything about it. Right? We got one last theorem to talk about, and then we're pretty much almost done with talking about theorem-y things. We have the congruent parts of congruent triangles are congruent, or Cpctc theorem, right? So again, the name is not super important. This one's telling us that if two triangles are congruent, then their corresponding parts are congruent, right? I know that sounds pretty similar to the last one we were doing. If you just wanted to think about them as almost the same thing, that's all right. This one's very specifically for triangles. The one on the last page was talking about any figures, right? But for our purposes, we're going to think about them pretty much the same way. All right, so we got a couple of different things we're going to do here. So it's giving us that triangle TOP is congruent to triangle CAN, right? So let's take a second here. I'm going to draw out two triangles, and I'm going to try and get them to look the same, right? So zoop and zoop, right? More or less the same, right? I know that I'm cheating a little bit, right? It's kind of like snapping the shape for me and whatever else. Just try and get them to be close to the same thing, right? So we're going to name one of them triangle TOP, and this other one is CAN, all right? So unfortunately for us, right, the order that we write those in does matter, right? And I guess I should have mentioned that before you probably wrote yours in, right? Because when we're saying that these two things are congruent, the order of the letters matters, right? If I look at these two shapes, right, they look like they're in kind of like the same orientation, right? They're facing the same way, more or less. The first letter needs to match up with the first letter in the other, triangle, right? So T and C being kind of like the top point of this triangle in each one matches up pretty well. O and A also have to match up. They're kind of like that little right angle looking thing down on the bottom left. And then last but not least, P and N are also going to be, just kind of the last side, right? So we do want those things to match up as we go, right? So what we're going to do is we're going to sketch and label these images and then list the corresponding sides and angles, right? So first things first, to name the corresponding sides, right? So all I'm going to be doing is I'm just going to put markings on them when they match up. Those seem like they would match up pretty well, right? So T to O and C to A, right? Those would match. A little further on, we've got O going over to P and A going over to N. Those also match up. And last but not least, we got the third side, right? We have from P to T and from N to C. Right, so you might notice that I put little like different numbers of markings on each one. Right? I also color coded them, but again, I know that a lot of you are probably writing in one color, so you'd use multiple. Right? All the ones with one marking match up with the other ones. The ones with 3 match, and the ones with 2 match. Right? So thinking about the sides, if I was to write these out as statements, right, I would say that TO, that line segment, right, so I'll put that little line over the top, is congruent to segment CA. Right? So that's the stuff that I've got in red. If I kept on going around, segment from O to P is congruent to the segment from A to N. And last but not least, you can do these ones in either order, right? You could do PT or TP, whatever. Keep going in the same order. The segment from P to T is congruent to the segment from N to C. All right, so that's how we would label the corresponding sides. Right, so I know that like you have more space off to the side. I'm going to try and scooch this over just so I can have a little bit more room and keep the triangles on the screen as well. All right, so that's all the sides. Goodbye. As far as the angles go, we're going to take a look at those as well. I'm going to again use red, blue, and black, so if you're following along with that, right, going to use the same idea. Angle T up here is going to be congruent to angle C in the other one, right? Because again, they're kind of in the same location. They're corresponding. Angle O is going to match up with angle A. And then angle P is going to match up with angle N. All right, and again, notice that I put different numbers of little kind of arcs into each one of those, right? Just to kind of show which ones match up. So again, if I'm doing the angles, if I'm trying to match them up, angle T is congruent to angle C, right? If I wanted to be super specific, I would call it like angle OTP and angle ACN, right? But if there's only one angle that's really around that part of the triangle, we're going to just use one letter, right? Keeping on going, right? Angle O is congruent to angle A, right? Those match up. Angle P, to finish things off, is congruent to angle N. All right? So we've got these sides that we kind of matched up to be the same and wrote statements for. We've also got these angles, right? And again, it matters what order you write the letters in your triangles, right? Angle T, triangle TOP and triangle CAN. I put them kind of like I labeled those triangles in the same order, right? So I'd like you to do is pause here, leave this one on the screen, and try out number 6. So hopefully you gave it a go, right? This one's talking about a big cat, right? So I'm going to try and catch up with where you probably are, right? If you didn't give it a shot, right? You know, now's a really great time, right? Let's just say that this was triangle BIG, and this other one is going to be triangle CAT. Oops, the second one's going to be a little bigger. All right, how about, again, let's use a little bit of movie magic. Cheat it out a little bit. There we go. If the second one is CAT, right, again, I kind of want to name it in the same way I did the other one, right? I started in the top left, I then named the top right, and then I went down to the bottom. All right, so what we're going to do, right, same thing. B and C kind of match up, so I already know I can do something with the angles, right? B and C match. If I'm looking at I and A, again, those are in the same part of that statement there. So I and A are also going to match up. Last but not least, G and T also match. Right, we're going to put 3 little markings in each one of those angles. Right, so that is a really easy way to start off, right? I just went in order of the letters, named those, matched up those angles just like that. After that, it becomes a little bit easier to do the sides, right? I can go from the angle with 1 measure to the angle with 2, right? I can specifically look at that side on each triangle. Call that the first side, right? Then I can go from the angle with 2 markings to the angle with 3 markings in each one, right? So then that matching side is going to have 2 markings on it. And then the third one goes between the angles of 3 and 1 marking. We can match those up as well, right? To name these, right, I'm going to do the same thing as we did on the last one. Angle B is congruent to angle C. Angle I is congruent to angle A. And angle G is congruent to angle T, right? So that's all the angles. As far as the sides are concerned, right, same deal. The segment from B to I is the same as the segment from C to A, right? That's what that red marking is telling us on that side. Segment from I to G is the same as the segment from A to T. And last but not least, G to B is congruent to T to C, right? So again, we're just matching up the pieces that go together, right? That's really all we're worried about on this, right? The very last thing that we're going to talk about on this are the properties of triangle congruence, right? So they're not, of premium importance for what we're doing right now, but they do exist, right? So let's talk about them real quick. Reflexive. If I've got a triangle congruent statement that says I've got triangle ABC, then I can say that it's congruent to itself, right? Triangle ABC is congruent to triangle ABC, right? This is one that's kind of like a, well, duh, right? Like, if I have the number 5, it's equal to the number 5, right? It's saying that it's equal to itself, right? So that's what reflexive is. As far as symmetric goes, right, if you have triangle ABC, it's also going to be the same thing as triangle CBA. You can actually kind of name it in reverse, right? That would also work out just fine. And then last but not least, we got the transitive property, right? So if I have triangle ABC that's congruent to triangle DEF, right? And triangle DEF is congruent to triangle GHI. All right, so if we have both of those, then what we can say is that triangle ABC is congruent to triangle GHI. All right, so the transitive property is definitely the weirdest one, right? It took a lot more writing to talk it out. And what's going on here is we're saying that, all right, I know that ABC is the same thing as this. Well, if that thing is the same as GHI, then these two things should also be the same, right? If you think about it, kind of like a plane, right? If you've ever flown somewhere and had a layover, right? You're still going from point A to point B, right? You're still flying from here to somewhere else, right? It's the same as if you took a direct flight from here to that somewhere else, right? Means the same thing. The layover doesn't really change the fact that you're still going from one to the other, right? Because it's, you're getting to and then leaving from the same place in the middle, right? So that's what transitive is. So if you're feeling a little iffy on any of this, please be sure to ask next time you see me. And as for now, I'm going to let you go. Goodbye. Oops, that's the calculator. Here we go.